Hello, geometry people. Here is a second lesson on proofs. Today we're going to introduce a concept known as corresponding parts of congruent triangles are congruent. It gets abbreviated CPCTC. The main concept here is, instead of being asked to prove two triangles are congruent, we're asked to prove two parts. But it's really not much different because instead of proving the parts, you have to still first prove the triangles, and then you get the parts congruent by CPCTC. So let's look at what's given, and let's make markings accordingly. And from our markings, we'll decide how we're going to go about this proof. So we have PQ perpendicular to QS. Here's PQ, here's QS. Perpendicular means they make right angles. So let's mark the right angle right there. Also, TS perpendicular to QS, we have another right angle between TS and QS. So make a right angle there. Now, we're also given R is the midpoint of QS. Here's QS, there's R. What does the midpoint mean? It means it cuts it into two equal parts. In geometry, instead of equal, we say congruent, but congruent and equal mean the same thing. So two equal parts, if R is the midpoint, that means that QR is congruent to RS. Now, to prove these two triangles, because those are the triangles we need, if you look at where P is, here's P, angle P, and angle T is here. So there's angle P, angle T. They're inside these two triangles. So first, before we can do this, we have to prove the triangle's congruent. We have an angle and a side. We need something else. Well, we can get this right here. These are vertical angles. Those two angles are equal. So now these two triangles are congruent by angle, side, angle. Angle, side, angle. Now the words I just said and the markings I just did are the proof. All the proof really now is just to write down what we did. Okay? So now remember, we have statements and reasons, and we always start with the givens. We were given that PQ is perpendicular to QS. I'm going to put them both on the same line, and TS is perpendicular to QS. That was a given. And our second given was that R is the midpoint of QS. And those two were given. Now, let's start listing out what I marked. What I marked first were two right angles. Well, let me say that then. Let me say angle Q and angle S are right angles. Well, what's the reason? Why did I mark that? Because they were perpendicular. Perpendicular lines form right angles. Okay? Now, what else did I mark? I marked QR, that line segment. Oh, before I go ahead and do that, and it really doesn't matter what order you put things down in a proof, as long as what you're trying to prove is at the end. If they're right angles, it means that they are congruent. We do want to say that. Angle Q is congruent to angle S, and that's simply because all right angles are congruent. Now, I marked these two segments congruent. Why? Because R is the midpoint. I'm going to write that down now. QR is congruent to RS. Why? I can write definition of midpoint, or I can say a midpoint divides a line segment into two congruent parts. Okay, now, I then marked these two angles congruent, the ones that are kind of in the middle, that have the vertex of R. I'm going to use the three-letter name here. Notice on angle Q and angle S, I was okay to use one letter, but here I have to use the three-letter name. So I'm going to say angle PRQ is congruent to angle, the one on this side is TRS. And why did I mark them congruent? Vertical angles. All vertical angles are congruent. Now, I have just proved those two triangles congruent. Let me slide this down a little bit to make room so I don't run out of room here. These two triangles are now congruent because I have shown angle, side, angle. These are just little markings to remind me of what's going on. So I'm going to say triangle PQR is congruent to triangle TSR, and the reason is angle, side, angle. Recall those reasons, angle, side, angle. Now, here's where it makes this proof different. Previously, we were done there, but we're not done until we're trying to prove what we're trying to prove. Now, these two angles, P and T, are inside those triangles. So once the triangles are congruent, all 6 parts, remember the 6 parts, 3 sides, 3 angles, all 6 parts are congruent also. So I can list anything congruent, but I'm just going to do P and T because that's what we're asked to prove. And the reason is corresponding parts of congruent triangles are congruent. Okay? And that's finishing this proof.